Okay, so today we're diving into something, well, pretty fascinating.
Definitely.
The intersection of artificial intelligence and the really abstract world of mathematical research.
Yeah, sounds almost like sci-fi, doesn't it? But it's very much happening now.
It really is. And it
Yeah.
seems like it's starting to reshape, how math actually gets done, how
Right.
discoveries are made, how proofs are built.
Absolutely. And for this deep dive, we're drawing heavily on a discussion with the mathematician Yang Hui He. He gave this really clear framework for understanding how AI is plugging into math right now.
Okay, good.
Uh,
So our mission then is to unpack that. Look at the different ways AI is helping out, what it means for mathematicians themselves, and maybe peek ahead a bit.
Exactly. And one of the surprising things, maybe, is that it's not just about crunching numbers faster. It's starting to touch on something much more, well, human.
Like intuition.
Precisely, mathematical intuition. But let's start with the framework.
Right. Yang Hui, he breaks it down into, what, three main ways AI is assisting.
Yeah, three distinct modes, as he puts it. The first one is what he calls top-down, or intuition-guided discovery.
Top down. Okay, and how does that feel compared to, traditional math?
Well, in terms of the style of discovery, it actually feels quite traditional, like how a lot of big breakthroughs in math and physics have historically happened.
How so?
You start with a spark, right? An intuition, a pattern you notice that just feels significant, a hunch.
Uh-huh.
And you pursue that hunch, you build on it, and only later, sometimes much later, do you nail down all the rigorous formal proofs.
Ah, okay. Like the classic example of Newton inventing calculus. He had the core ideas, the framework.
Exactly. Long before things like the rigorous theory of convergence were fully developed to back it all up formally.
So in this top-down mode, AI isn't writing the final proof.
No, not really. It's more about helping in that initial fuzzier stage. It might analyze data and suggest unexpected patterns, or propose conjectures that look promising, or even draw connections between fields you hadn't considered.
So it's like an assistant for the brainstorming phase, a muse almost.
Kind of, yeah. It gives you directions before everything is perfectly structured and defined, helping with that initial creative leap.
Interesting. Okay, so that's top-down. What's the second mode?
The second mode shifts gears quite a bit. He calls it meta-mathematics. And this is where tools like, the large language models, ChatGPT, DeepSeek models like that really come into play.
Ah, the LLMs. So how do they fit in as, like, research assistants?
Exactly. Think of it as a super-powered research copilot. You need to brainstorm proof strategies. It can help. Need to recall some obscure theorem you half remember.
It can pull it up instantly.
Right. Or generate potential conjectures based on scanning huge amounts of literature. Or just synthesize information from papers way faster than any human could read them.
I know the mathematician Terence Tao has talked about using these tools.
He has. And specifically in this meta-mathematical way. Not asking it to write the proof, but using it to, say, suggest different angles of attack for a proof. Or point him towards mathematical tools or theorems from adjacent fields he might not be familiar with.
So it expands his immediate toolkit, his working knowledge, almost on demand.
Precisely. It's like having an incredibly knowledgeable, very fast assistant to bounce ideas off and fetch information.
Okay, so top down for the initial spark, metamathematics for navigating and assisting the research process. What's the third mode?
The third is bottom up. This is formal proof automation.
Right, this might be what some people immediately think of AI just doing the math.
Sort of, but it's very different from the other two. This involves systems like Lean or other formal proof assistants.
And these are more rigid.
Incredibly so. They are deeply mechanistic. They work by taking established mathematical logic, formalizing vast amounts of it, and then using that rigid structure to meticulously check proofs step by painful steps.
For absolute certainty.
For absolute, unassailable rigor. Especially useful for verifying extremely long, complex proofs where human error could creep in. It's about locking down the final details.
Okay, so these three modes seem to cover different stages of research. Top-down for inspiration, metamath for assistance during, and bottom-up for final verification.
Exactly. The source had a nice analogy for it, the research rocket.
Oh, yeah.
The top-down intuition part is like the initial inspiration and design, deciding where the rocket should even go.
Okay.
The metamathematics, the LLM copilot, so that's the computer-assisted dashboard during the flight, helping navigate, giving real-time data, suggesting course corrections.
Makes sense. And the bottom-up.
That's the engineering team doing the final mechanical checks, making sure every single component is perfectly sound and verified before you declare the mission a success.
That's a really helpful way to picture it. Different tools providing leverage at different points.
Yeah. From the very first glimmer of an idea to the final published proof.
And interestingly, these different approaches seem to align well with different styles of mathematical thinking. The source mentions that old metaphor.
Ah, yes. Vladimir Arnold talked about it, tracing back to an ancient Greek fable, hedgehogs versus eagles.
Or sometimes foxes, right?
Right, sometimes foxes instead of eagles, but the idea is the same. Hedgehogs are the deep specialists.
They find one big problem and just dig in, focusing intensely until they crack it.
Exactly, burrowing deep. While eagles or foxes are the broad thinkers.
They fly high, see the connections between different areas, maybe even different fields entirely. They synthesize.
Precisely. And AI tools can help both types.
How so?
Well, for the hedgehog, the deep diver working on a complex proof, those bottom-up formal proof assistants can be a lifesaver. They automate the incredibly tedious step-by-step verification.
Freeing up the hedgehog to focus on the core intellectual challenge, the really hard part.
Exactly. And for the eagle, the connector.
The metamathematics tools seem perfect. The LLMs.
Right. They can scan vast amounts of literature across many domains incredibly quickly and suggest potential connections, cross-pollinations of ideas that even a human eagle might miss or take years to find.
So regardless of your personal style, whether you like to go deep or go broad, there are AI tools emerging that can amplify that strength.
That seems to be the case. It's becoming an amplifier for different cognitive styles.
And this isn't just theory, right? There are actual examples of this happening now.
Oh, absolutely. The source shared a great anecdote. A number theorist was working on a problem. She'd prove one lemma, a smaller stepping stone result.
A helper theorem.
Right. And she had another lemma she was pretty sure was true, connected to the first one, but she was completely stuck on how to construct the proof.
Okay, classic research roadblock. What does she do?
She took the lemma she had proved, pasted it into ChatGPT 4.0, and basically asked it for a strategy or a structure to prove the second lemma.
Right.
And the AI spat out a symbolic structure for the proof that was mostly correct.
Wow. Seriously.
Yeah. Now, she still had to do the real work, right? Check every detail, polish it, ensure logical soundness, turn it into a proper, rigorous proof.
Of course. It didn't do the thinking for her.
No, but it gave her the blueprint, the scaffolding. And that turned what could have been days, maybe weeks, of frustrating trial and error into a matter of hours to refine the AI suggestion.
That's a huge difference. Days into hours.
Massive accelerator. And another practical use case mentioned is just getting up to speed quickly.
On a new topic.
Yeah, using something like DeepSeek or ChatGPT to get a quick overview of an unfamiliar area of math. The source even suggests this can sometimes be better than asking a human expert.
Really? Why is that?
Well, an expert might dive into nuances you don't need yet, or assume background you don't have. The AI can sometimes give a more tailored, high-level summary faster, which is crucial if you're exploring connections across fields or just need the gist quickly.
So these tools are already saving time and effort in tangible ways for researchers today.
Definitely. It's not just futurizing.
Which naturally makes you think about the role of the mathematician itself. How is that changing?
Well, think about the history. Decades ago, mathematicians were the computers, essentially, doing all the calculations, all the derivations by hand.
Right. Then tools like Wolfram Mathematica came along.
And suddenly, complex integrations, basic calculations, even some elementary proof steps could be outsourced to the machine. The human role shifted more towards strategy and problem setting.
And the prediction now, looking ahead maybe 10 years,
is that this trend just accelerates dramatically. The source suggests mathematicians become more like deciders or directors, meaning they focus less on the nuts and bolts execution, the laborious computation, the painstaking formalization, and more on setting the research direction, asking the right questions, formulating the core problems.
And then guiding AI agents to handle the more labor-intensive parts of finding the solution or verifying it.
Exactly. It's a shift from being the artisan doing all the work to being the architect guiding a very capable team.
And you can imagine, if your work involves any complex problem solving, how the valuable skills might change. Less about manual dexterity, more about strategic oversight and critical judgment.
It really changes the emphasis. And perhaps the most profound shift discussed is how AI might start to support intuition itself.
This comes back to that practice before foundation idea from Yang Hui.
Right. The historical fact that so many huge mathematical leaps started intuitively. Someone saw a pattern, had a hunch, felt something was true, long before they or anyone else could rigorously prove it.
That messy, creative, pre-rigorous phase.
Exactly. And that's where AI's role gets really revolutionary and frankly surprising, assisting in that fuzzy front end. Because intuition is hard to define, hard to train AI on.
You can't just feed it intuition data.
Right. But it seems these LLMs, trained on just massive amounts of mathematical text and symbols, are starting to develop some capacity to, well, almost mimic that process, to explore ideas that aren't yet fully formed.
It touches on something deep about human thinking, doesn't it? We often don't even know the exact problem we're solving until we're partway through exploring it.
That ability to operate in ambiguity, to push forward without a perfectly defined goal yet, that's key to human creativity.
And traditional AI, the very logical, rule-based kind, couldn't really handle that.
Not well. But these newer models seem to have a surprising ability to engage with that ambiguity, to help us wrestle with and shape mathematical concepts that are still emerging, still lack that crisp formalism.
Helping us in the most human part of the process, the initial spark, the shaping of a new idea, that feels huge.
It's potentially transformative. How does AI assisting intuition change the very nature of mathematical creativity? It's a big question.
And it really underlines the point that this isn't just about getting new software. It's prompting a fundamental rethink of what doing mathematics actually means now.
Yeah. There's an analogy in the source. Calculators changed how we did arithmetic day to day. Wolfram Alpha changed calculus workflows for students and researchers.
And now these AI copilots, ChatGPT, DeepSeek, Lean, the proof assistants, they're doing something similar but at a much higher level of mathematical exploration and validation.
It definitely makes you wonder about education. How should we teach math if exploration and validation are increasingly AI-assisted?
Does the focus shift even more towards problem formulation, strategic thinking, critically evaluating AI output?
It seems likely. Knowing how to use these tools effectively becomes a key skill, maybe the key skill.
It's a massive shift happening. And there's that one quote from the source that really hammered it home.
Yeah, the stark one. AI won't replace mathematicians.
But mathematicians who use AI will replace those who don't.
It really captures the likely reality. The leverage these tools provide is just too significant to ignore.
So maybe the final thought to leave you, the listener, with is this. How does this dynamic, this interplay between your own human intuition and the growing power of AI, how might that shape the way you approach creativity and problem solving, whatever your field might be?
It's a question with implications far beyond just mathematics.
Absolutely. Well, thanks for joining us on this deep dive into a future that's arriving faster than we might think.